Hello everyone. In this video I'm going to go through all the examples in exercise 11C, completing the square. So, completing the square, it's a method for you to solve a quadratic when factorizing that we've done doesn't work. Alright, this utilizes perfect squares, which we learnt about last term. Alright, so I've put it over here as you can see. Alright, and I've also drawn a little diagram, and this is what we mean by completing the square. Alright, we're trying to find basically what value we need to add onto the expression to turn it into a perfect square. Once we do that, we can actually solve it. Okay, you will also notice that once we solve these equations, the solution is irrational, so you're going to have surd answers. Alright, that's why factorizing doesn't work. Okay, let's have a look at this example 8. So, for each of the following questions, find what must be added to both sides of the equation to create a perfect square on the left-hand side. Part 1, and then part 2, write the equation in the form x plus p squared equals k. So let's have a look at part A. So we have x squared plus 8x equals negative 5. Okay, so we want to turn the left-hand side into a perfect square. To do that, we need to add a constant. Okay, now when you're solving by completing the square, you want to put all the x's on one side of the equation and move the constant to the other side. Alright, so and you'll recognize that as you do more. So right now we have x squared plus 8x. Now I've given you a quick method to find out what you need to add every single time. So this works every single time. What you need to do is find the coefficient of x. In this case it's 8. And then you're going to halve it, and then you're going to square it. So if we halve 8, it's 4. If we square 4, it gives us 16. So 16 is the number we need to add to both sides. Okay, and we need to add it to both sides because it's an equation. Whatever we do to one side, we have to keep it. We have to do the same to the other side to keep our equation true. Okay, so we can do the same for b as well. Right, it doesn't matter if the coefficient is positive or negative. You always have to end up adding anyway, because let's try this. Let's have a look at the coefficient of b. So we got x squared minus 6x, so the coefficient is negative 6. I halve that, I get negative 3. If I square negative 3, it's going to be positive 9. Okay, so see how, understand that it's always going to be adding. Okay, let's do part 2 of each now. So I need to write the equation in the form x plus p squared equals k. So this is always going to be like your process for completing the square. So you figure out what you need to add to each side, and then you actually do it. So make sure you add 16 to both sides. So if I add 16 to negative 5, I get 11. Now you want to factorize. Now that you've added on your constant, the next step is for you to turn it into a perfect square by factorizing. Alright, so the reason we added 16 is because now we can factorize this into x plus 4 all squared. Okay, and then we're not going to solve it here because we're done. And let's do b. So we need to add 9 to both sides. So we get 22. Now this one becomes x minus 3 squared equals 22, and we're done. So that's example 8. Solve for x by completing the square. Leave your answers in simplest radical form. Okay, let's begin. So if you're using complete the square, well, it's probably easier to have one side with your x squared term and your x term, and move the constant to the other side. So that's what we're going to do here. So we're going to add 2 to both sides, gives us x squared plus 2x equals 2. Now I need to think about what I need to add to both sides to complete the square. So I half the 2 to get 1, and I square it, which is still 1. So I need to add 1 to both sides. Right-hand side becomes 3. All right, because now my left-hand side is a perfect square. It becomes x plus 1 squared, and that equals 3. Now we have to solve it. So back to last lesson, okay, this is where we have to square root both sides, and remembering that when we square root both sides of an equation, we end up with plus or minus. Okay, so the solution right now is x plus 1 equals plus or minus root 3, and then take 1 away from both sides, so x becomes negative 1 plus or minus root 3, and that is it. That is our solution in simplest radical form. Let's do B. So same idea. I'm gonna keep the left-hand side, keep all the x's on my left-hand side, and take away 3 from both sides. Then I'm going to decide what I need to add to both sides. Okay, this one we're going to have to start using fractions. So if we half negative 5, we're going to have negative 5 on 2. And if we square that, we're going to have 25 on 4. Right, when we square a fraction, we square both the numerator and the denominator. So that's what we have to add to both sides of the equation. Okay, so maybe I'll write that here. Half negative 5 is negative 5 on 2, and then negative 5 on 2 squared is 25 on 4. So you will have to use fractions if the coefficient of your x is an odd number. Right, so even though it's a fraction, my left-hand side is actually a perfect square now. So it's x minus 5 on 2 squared equals, now negative 3 is the same as negative 12 on 4, so negative 12 plus 25 is 13 on 4. Okay, then we solve. Equals square root 13 on 4. And then let's add, oh, almost forgot the plus minus there. And then to get x, let's add 5 on 2 to both sides. I like to put the rational number before the plus or minus. So I like to put 5 on 2 first, then plus or minus root 13 on 4. We can actually simplify that. So I'll write it like this first. And then remember when we square root a fraction, we can square root the numerator and square root the denominator. So whenever you can do that and make the answer look a bit neater, you can. Oh, and then now I see that my denominators are the same, so I can actually keep going. So this will be 5 plus or minus root 13 over 2. Alright, there's my solution to example 9b. Okay, let's do example 10. Solve for x by completing the square. X squared minus 4x plus 6 equals 0. Okay, so x squared minus 4x equals negative 6. Okay, now I'm going to complete the square on my left-hand side, so I'm going to half -4 and square it, which becomes 4. So that means I have to add 4 to both sides. And then let's factorize into our perfect square. Okay, now from here, I realize that I have to square root both sides, but my right-hand side is -2. If we square root -2, we're not going to have any real solutions. So we just say no real solutions. Okay, example 11, last one. Okay, now this time it's a bit different to all the other ones we've seen because now we have a coefficient for x squared, but I'll show you how to deal with that. So you still want to keep the x's on the left side or one side and move the constant to the other side. Now you actually want to divide, or actually you want to factorize 3 out of the left-hand side. Right, basically you just want x squared on the left-hand side, okay? Just to make things easier. Then you're going to divide both sides by 3, okay? Now, let's turn the left-hand side into a perfect square. Okay, so hopefully you're starting to get the idea. So add 1 to both sides. Then we have a perfect square on the left. And 1 is the same as 3 on 3, so 2 on 3 plus 3 on 3 is 5 on 3. Okay, then let's solve. X plus 1 equals plus or minus square root 5 on 3. That means x equals, take away 1 from both sides, 1 plus or minus the square root of 5 on 3. Now, I'm just thinking whether or not to take this a little bit further. I think I will, because we've looked at how to simplify surds. Alright, so I'm going to do it separately here. There's a bit of a process. So x equals -1 plus or minus. Now root 5 on square root 5 on 3 is root 5 over root 3. Okay. I see that root 3 is irrational in the denominator, so I'm going to rationalize that like this. Okay, so I'm going to have -1. Now that doesn't change the value of my solution at all, because root 3 on root 3 is 1. So this gives me root 15 on 3. Okay, now I'm going to turn -1 into a fraction because I see that I have a denominator of 3. Okay, now, so my job is to make them both the same denominator. And now I can write this as 1 complete fraction. Alright, so that's what you want to try to do, rather than having a constant and a fraction. Try to simplify it into 1 fraction when you can. Alright, so there are some examples of how to solve by completing the square. Alright, now you can complete the questions I set for you in exercise 11C. See you in the next video.